We'll go through We'll go through some of the homework questions first that I asked you to try yourself. 1.8. 1.8. Okay, calculate the acceleration. I think this one is not a difficult one, so very quick. We have U here, V here. I hope you have tried now, U and V. And to find out the U, we will go and do distance divided by the time. Distance is 10 cm. You can write 10 cm or 0.1 meter. By now, I hope you are a pro at this. And then each cutout consists of 10 ticks or 0.2 seconds. So you actually don't have to go and times 10 by 0.02 yourself, right? Because they already told you each strip is 10 ticks. 10 ticks or 0.2 seconds, same. Okay, so I think you can straight away use 0.2 seconds now. So it will just be 0.5 meter per second. Okay, quick one. And then V. V is 30 cm or 0.3 meters. Okay, 30 you divide by 100, 0.3 meters. Again, each strip is 0.2 seconds. Right? How come they can say ticks and seconds in the same sentence? Is because ticks memang refers to the time, right? Okay, ticks memang refers to the time. So if I say one tick, that is the time for one tick. The time for, sorry, the time for two consecutive dots, between two consecutive dots. If I say 10 ticks, then it's the time for 10 consecutive, the space between 10 consecutive dots, right? So, oh, sorry, 10 ticks is 11 consecutive dots, because two dots will give you one tick. Yeah, that one is not so important. You get what I'm trying to point out. Okay, after you get these two, we can quickly find out acceleration. Formula is final minus initial velocity divided by time. Right. So the final velocity, 1.5, no issues. Initial velocity, 0.5. If you forget which one is U, which one is V, remember I told you, they go in alphabetical order one. U comes first before V, therefore U is the one at the start, the one at the initial one. Okay, V is the final one, right? Divided by the time. Each of the strip is 0.2 seconds. So we have 1, 2, 3, 4, 5 strips in total. 5, remember, always need to minus by 1, right? So it's just 4. Just 4 strips. Each strip is 0.2. So I can just use 0.2 straight away. Calculator. So that would be 1 point something. 1.25 meter per second squared. Okay, I hope you know why I minus by 1, because U starts from, U is at the middle. This is the value of U is the average velocity in the middle of the strip. V also is at the middle of the strip. Okay, so we only start counting from here to here to here to here until here. Stop here like that. Okay, so the acceleration, I need to minus half. That's why in total minus 1. So I only count 4 strips, not 5. Okay. Tomorrow exam. Okay, Ethan, tell me tomorrow exam. Good luck with your exam. I know some of you have, DJ have Marintas Desa tomorrow. Good luck with that as well. Okay, I'm definitely slower than your school because this is just our 3rd class, right? Right, I'll give you 20 seconds. If all is good, I'll move on to the next homework question. I hope you tried it yourself. Give you a chance to try yourself. Okay, all good. Move on. This one, 1.10. Okay, this is a slightly longer question, and I hope you were okay doing this. Let's have a look. The figure shows a ticker tape obtained from a trolley moving on a plane. Each strip of ticker tape contains 10 ticks. Okay, this one is important info. The electrical supply to the ticker timer is 50 hertz. 50 hertz. All right, so now they want us to calculate the time. What is the time taken for each strip of 10 ticks? 10 ticks. 10 ticks meaning you have to just take 10 times. Each tick is 0.02, counting 0.2 seconds. So next time you know, if you need the time for each strip, it will just be 0.2 seconds. Okay, you don't have to go and times yourself again because you already did in part A. Part B, describe the movement of the trolley based on the ticker tape above or beside lah. Okay, based on the ticker tape here. So you see a staircase going down, going down, going down. You can definitely see that. Let's say without calculating, you ask yourself, is it getting faster or slower? And how to tell? You just ask yourself, will the velocity here and here be different or not? Definitely. Okay, definitely. The U value here is larger. The V value here is smaller. Okay, so you have slowed down already, right? Slow down meaning deceleration. Okay, so you can actually say constant deceleration because this staircase is constant, right? It goes down uniformly, constantly. So you can say constant deceleration. Your teacher will look out for this keyword. Okay, your teacher will look out for this keyword. If you want to write in a proper nice sentence, you can say the trolley moves with constant deceleration. If you want, okay. And then part C. Remember we said you can also say, I think constant deceleration is a good answer. Okay, but if you want to say velocity decreases uniformly also can. But if you ask me, I prefer constant deceleration. Sounds more pro. Okay, that means you really analyze and you know what is going on. Decelerate, always remember, means slow down. Accelerate means speed up. Okay. C1, what is the initial velocity? Let's calculate. That is 22 cm or 0.22 meters. Okay, U and V, divided by. Remember, don't need to calculate the time yourself again. You can just use this 0.2 seconds because each strip is 0.2 seconds. Okay. Then final velocity, that is 2 cm only. So 2, be careful. 2 means 2.0. You want to divide by 100. 1, 2. Decimal point come here. 0.02. 0.02 meters. Usually I prefer SI unit lah. Save the problem in case you don't know what you need to write and things like that. But be careful lah. Sometimes the question will say, please leave your answer in meter per second like that or cm per second, then you follow. Okay. Not very often though. Last one, acceleration. Formula is v minus u over t. We have 1, 2, 3, 4, 5, 6. 6 strips. Okay. I cannot do 6. 6 salah. Remember that?
Aye.
2 to minus. Yes, correct. Thanks for answering. I don't know who's that. Bradley. Okay. Yes, 5. 5 times 0.2. Again, kenapa 0.2? Sebab ini for one strip already. You have already calculated. So remember, if you calculated already, you don't need to keep calculating. Okay, you can straight away use 0.2. Important, this one, not 6. You can use red pen, circle, highlight, so that next time you do revision, you know what's going on. Okay, need to minus 1. And we can expect our answer to be a negative value because slow down, right? Acceleration, the positive or negative value means speed up or slow down. Okay, speed up or slow down. So -1 meter per second squared. Okay, I hope your answers same as mine. Again, I give you 30 seconds. If you need more time, let me know. Then I'll move on. Those of you who have exam now, your school test until well, 2.1. Ethan say 2.6. What school are you from, Ethan? 2.6. Until Tropicana. Okay. Kirina say until 2.2. Okay. Jashan 2.4. Well, I'll try my best. I'll see what I can do today, okay? But like I said, today is just the third class. So I hope at least you have a better understanding of the front parts, okay? Wow, Courtney, yours is in August. By the time I think your exam will test you on more things in here. It won't be until chapter 2 point something. Okay, I move on. Did I give you guys homework? Oh, this one is, okay, sorry. Right, so last week, I think, I hope I'm right. I hope my memory is serving me right. I think Zehan asked me a question at the end of the class. He stayed back to ask me a question, right? So which is something that I think I need to highlight to all of you also. Do you remember that at the beginning we learned that generally, velocity, the formula is displacement divided by time. So the question here is this velocity also the same as the final velocity that we are doing in this part of the topic? Okay, because let's say we have somebody walking a distance of 100 meters and the time is 5 seconds. In 100 meters, 5 seconds, sorry, cannot. 20 seconds, again, 20 seconds, walking, 20 seconds, right? Can I say that the final velocity, the V, is 100 meters divided by 20 seconds? Can I say that? What do you guys think? Is it correct? Yes, Sherwin. Okay. Means you have successfully fallen into my trap, right? I think this is the problem with some students. They struggle with this part, right? You have to ask yourself, right? The V here, final velocity, means the velocity at the end. U here stands for velocity at the start. They are both equals to S over T. Both equals to S over T. But is the S for what? For the starting part only. Is the V for what? This one is the S for what? For the back part only. Okay, for the back part only. So you cannot say that the final velocity is equals to this. You cannot say that the final velocity is equals to this because 100 meters for the entire journey, not for the front part, not for the back part. Understand? Not for the front part, not for the back part. Okay, but if I say this one is the average velocity V, no problem. Okay, average velocity for the whole journey. That is to talk about the whole journey, no problem. Okay, the problem comes when you say this V is final velocity. So you need to know, sometimes this V a bit confusing because it has many meaning. Right? Depending on the situation, it could mean final velocity. It could mean average velocity, right? Really depends. So you need to look at the question and you ask yourself, does it make sense or not that you have. Okay, hold on, Ethan. Does it make sense not that you have the whole journey 100 meter and then you say that the final velocity is using that data? No, cannot, right? So if the question asks you something like this, can we actually find out what is the U and what is the V? Tak boleh lah. Cannot. Okay, cannot. Because I don't know, I have no information at the start of the journey and at the end of the journey is what? Unless I tell you maybe at the start of the journey, it is at rest. Okay, it is at rest. And then at the end of the journey, maybe it will reach like 10 meter per second. It accelerates and then it reaches 10 meter per second. Okay, then that is the situation where your U and your V is different. Okay, or another situation where U and V is different is when you have thicker tape. Okay, thicker tape. Maybe you have a long strip. At first, the dot very close to each other, and then slowly it will space out more and more and more. Okay, this is an example of maybe the U value is different, the V value is different. Okay, the U value and the V value is different, right? Because the distance at the front and at the back, they are different. Okay, but if you're using the whole thing, then you are looking for the average velocity, not the final velocity. Can understand the difference between average velocity and final velocity? No, that's my point here that I want to make. Make sure you understand average velocity and final velocity. Final just for that final part. Not all the time you can get it though, right? Depending on whether or not they give you enough info. Average is for the entire journey. Okay, so this is when you can go up here, go and do your own notes. Go and do your own notes. Let me see where to put it would be best. Yeah, put here lah. Okay, so I'm going to put a star here. I'm going to put a star here. V is final velocity for linear motion equation. Okay, if you want to use these equations, the V must always mean final velocity. Your V here in this linear motion equation here cannot be talking about the average velocity. Okay. So don't use average velocity. Average velocity means what? Means velocity for the whole journey. Okay, actually already tell you lah, it's already here in the left side here. V is final velocity. Okay, but at least now I hope you have a better idea what kind of velocity is what. Whole journey, we're talking about generally the whole thing. There's no start, there's no end. I'm just talking about the whole thing. Average velocity. I'm talking about just the start. It's very obvious in the question. Don't have to worry about it. I'm talking about just the start. That is initial velocity. I'm talking about just the end part. That is the final velocity. Can everybody? Okay, good, Sandra. Okay, can I? Right, so back to this homework question. I hope I have cleared a bit of doubts because these things are quite important one. If you feel that these calculation parts are difficult, then it's usually on understanding what value is what. That is the difficult part. Okay, because I think just putting in the numbers and then calculating is just normal maths, just move here and there, right? So that part I feel no problem, and choosing the equation also is not too difficult. So physics need to understand one, need to understand what you're doing. Okay, so Zach asked me a question. Zach, can I copy your question and put to everyone in the chat? Okay, so this is what Zach asked. So basically, if we want to find average velocity, we use the ST. If you want to find out final velocity, we use the equation. You could say so. You could say so. But do you remember for ticker tape? For ticker tape, okay, you know what? Let me use this example. I don't think so you guys have space, but if you do, you can put this down. Let me use this example, this one. Okay, so this one is the initial velocity. This one is the final velocity. Sometimes you don't need, like for this case, do I need to use the equation? Don't need, right? Okay, I know the front part is U. I know the back part is V. Okay, but this one, apa maksud ini? Initial velocity. Okay, initial velocity. Apa maksud ini? Final velocity. If you have space, can I add one more? And I want to calculate the average velocity. That means for the whole journey whole journey, okay? For whole journey. But I need you to add one more piece of information here, which is, hold on. Hold on. Okay, I need you to add one more piece of information here. The whole thing is 24 cm. Okay, the whole thing is 24 cm. So for average velocity, how to find velocity for the whole thing? 24 cm or 0.24 meters divide by how many dots do you have? How many ticks do you have? Sorry, 1, 2, 3, 4, 5, 6. 6 ticks. Okay, the total time taken to reach from the first point to the last point need 6 ticks. 6 times 0.02. Okay, this is not finding acceleration, so don't minus 1. Only acceleration minus 1. Can you see the difference between the UV and the average velocity? One is calculate front part, one is calculate back part, one is calculate whole thing. Okay, as long as if you want to use the equations, the linear equations, you cannot treat the V as average velocity. Just remember the meaning of V is final velocity. Okay. Ethan can, but not the best way to do it. That is, so Ethan asked me, can I just take the initial plus the final and then divide by 2, just to find out the average velocity? He can, but that's not the best way to do it because average velocity, the formula is total distance divided by total time. or total displacement. Okay, so Ethan, that is assuming that the acceleration is always constant, right? You can do that, but sometimes it can be a bit risky, and your teacher might not understand what you're doing. Okay, so it's better to stick to the original formula. Okay. Everybody okay with the thing that I'm trying to point out, where in this equation, linear motion equation, V is what? Please don't say V is average velocity. V is always the final part. When I say final, make sure you mean final. Final means the last part. Okay. If you feel that you do V equals to you're talking about the entire journey, then something is wrong already. Okay. So I just want you to be more cautious with the V here. Okay, because this V must be talking about the final part. Okay, like there's a general V, the one we call it average for the whole thing. There is a very specific one, which is the final part. Okay, good, Daniel. Good, Zach. Don't worry so much. Just remember V is final. Okay, that's all I want to say. V is final velocity. Okay, so back to this question 1.16. 1.16. A trolley starts from rest. From rest, that means the beginning part is 0 meter per second. Accelerates uniformly over a distance of 2 meters. Okay, if the final velocity after traveling 2 meters is 2, final velocity is 2. You see not? Final velocity is 2. If you write V equals to 2, make sure V represents final velocity. That's just what I want to point out. Okay, what is the acceleration of the trolley? Okay, before we continue, let me pull out my formula first. It's my formula. I thought I screenshot. Okay, never mind. Wait. Okay, let me paste it down here so that you all can see. Okay, I don't want the T. So you find those that have T. Tak mau ini, don't want T, don't want T. Equation number 2. Okay, the selection of which equation I hope is not a big deal. Just remember to memorize number 3, because number 3 they won't give up. So you get your exam paper, you write down number 3 first. Okay, and then V is 2, U is 0, A is what we want to find, S is 2. Okay, slowly multiply. 0 just 0 lah. This one is 4A. So 4A equals to 4. A is equals to 4 divided by 4. Can I straight away write 1? Okay, if your original units are all in SI unit, your answer also will be SI unit. Don't have to worry. Okay, your answer also will be SI unit. I hope everyone can get this. Okay, this one was your homework. 30 seconds and I'll move on. Okay, while waiting, let me take the attendance. First, Okay, let's move on. 1.17. 1.17, 1.8, right? These are questions that you will see again in 2.3, okay? 2.3, freeform motion. Okay, freeform motion. But I want to discuss this because it's a bit related also, right? So now it's just to give you a glimpse of 2.3. We are going to do this a bit again, but it's similar. So to those of you who are going to cover 2.3 in your exams as well, this one is a good practice, right? A stone is thrown vertically upwards at a velocity of 2 meters per second. Okay, I have a stone. I need everyone's attention now for this question, because surely we'll have people to get confused on this one. Okay, I have a stone. At first, it is 20 meters per second. I throw it up. Okay, I throw it up like that. The gravitational acceleration is 9.81. Okay, I know a lot of students, they will ask when to use 9.81, positive 9.81, when to use negative 9.81, right? I'm sure a lot of you don't know this, okay, or not so sure lah. And then they say that the air resistance is neglected. They say that because actually if your air it has more and more particles, very dense, it will slow down whatever you throw up or throw down. Okay, so they say that there is no friction. You guys know what's friction, right? There's no friction from the air, which means it doesn't slow it down further. Okay, so I want to ask everyone one question first. One question, simple question. Okay, everyone listen up. If I throw something go up, does it slow down or does it speed up? If I throw something up, does it slow down or does it speed up? Slow down. Okay, Ethan says slow down. Slow down. Okay, Sharishna says slow down. Kirina also says slow down. Yes, you are right. Okay, if you throw something go up, it always slows down. It always slows down. Don't believe, try to throw something. Throw a ball, go up. Okay, if you go to, let's say PJPKR Padang, you kick the ball, go up. It will get slower and slower and slower until you reach that highest point, and it will start falling down again. And when it falls down, it will speed up again. So always remember, something that goes up, it's very difficult to suddenly float, go up, right? You cannot naturally float up, right? Because it's very hard to go up, right? It's getting harder and harder and harder to go up. You will definitely slow down. Okay, why? Because, okay, imagine this is the Earth. You learned about gravity roughly in PT3. Gravity is always pulling you down to the center of the Earth. Okay, it's always pulling you down to the surface. There's a constant pulling force that pulls you down, right? So if you throw something up, it's always going to go down. Throw something up, it's always going to go down, right? So it's always going to slow down because you are going against it. And I said, what is the meaning of acceleration? Speeding up or slowing down. Speed up, positive. Slow down, negative. So no more confusion here, I hope. If I go up, just ask yourself, am I getting slower? Yes. Acceleration, negative 9.81. All good. If I am slowing down, negative 9.1. If I am speeding up, for example, maybe the ball come down, then it's positive 9.81 because I am speeding up. So if you're not sure what to put for plus or minus for your acceleration, ask yourself this simple question. Because we learned this table, okay? This yellow color table in page 2. Acceleration increase means positive value. Okay, you can jot down yourself here, use red pen, blue pen, whatever. This is called speed up lah. Velocity increase means speed up. Velocity decrease means slow down. Okay, slow down. Speed up, acceleration positive. Slow down, acceleration negative. Okay, it's that simple. So please don't confuse yourself. Don't make life complicated and difficult for yourself. Okay, if you understand this, I move on. All right, so they say calculate the time it will take for the stone to reach the maximum height. Okay, to reach up here. We want to know if you throw the stone up at first it's 20 meters per second, but it's going against gravity. So slowing down, slowing down, slowing down. And the acceleration is therefore negative 9.81. How long does it take for you to reach the highest point there? All right, I cannot use this equation of linear motion because I only have three things involved here. I need that fourth thing, right? So I either want to know what is my S or what is my V. Okay, S or V. I don't know what is S. I know what is V though. You must remember that at the highest point, the V will always be 0. Because if you throw something go up, if you kick a ball up, the ball will go to the highest point and then it will come down. Right? And then it will come down. If let's say you kick it up, go up, and then it will come down. Okay. It will slow down as it goes up. Slow, 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 slow until it reaches the highest point, it will stop for a super short moment. Okay, slow down, slow down, slow down, and then it will stop there for a super short moment, and then it will come down very fast, speed up. Okay, that is why later on when you learn freefall motion, also the same, you throw anything up, at that highest point, the velocity will always be 0. That is what we call as stop for a super short moment means instantaneous rest. This one is extra info. Instantaneous rest. Okay, instantaneous. At that instant, it is resting only. Okay, this one not important. So it will stop there for a super short moment. Actually, all these things, right, you will learn in your Maths Form 5 Chapter 8 again. Maths Form 5 Chapter 8 again. Right, so just remember that. Ethan asked me, teacher, it's not A, it's G, right? A and G is the same thing. Okay, I don't like to use G, I like to use A. Same. Acceleration and gravitational acceleration is the same thing. You won't be marked wrong. It's all the same. Okay, so stop for a super short moment. And if can you guys use the public chat so that everyone knows what I'm answering to? If can, unless you're super shy. Okay, this one I move to the side. So you draw this very simple diagram. Okay, you draw this very simple diagram down here. Then you jot down here that it will stop for a short moment at the highest point. Okay, I hope you understand why. Because it was slow until it will eventually stop there, and then it will speed up again. Then it will go back to Earth again. Okay, go back to the ground again. Doesn't the rock initially start from rest, then gets thrown up? Yeah, and anything actually also start from rests, right? And then you throw up, right? So, but then we are talking about, actually you just follow the question now. Okay, we are talking about, we don't want to start analyzing from the moment it is on our hand, but the moment it starts the motion. Okay, from the moment it starts the motion. And then it will make sense because if you don't put u equals to 20, then this 20, you don't know where you want to put also. And you don't know what for you want to put, right? If you say that the u is 0, and then you say the v is also 0, it means it's not moving at all, Okay, so somebody, either the u or the v, cannot be 0. Okay, if one is 0, the other one cannot be 0. Or else that just means that, oh, this thing not moving at all, just stay there. Okay, so we start analyzing from the moment it start the motion. From the moment it start the motion. So the moment the rock is thrown up, immediately I measure the initial velocity then, that is the u, and then go up until v equals to 0. Okay, or else you Cannot put 20 anywhere else, right? Okay, so you just follow the question. U is equals to 20. I know it's confusing because the rock is at first resting and then you throw up, right? Yeah, but we don't want to include that resting phase. We want to start from, remember I told you that for a motion, you can cut it into different parts and analyze. I don't want, because the resting one is just, the velocity is just 0 the whole time. Okay, the velocity is just 0, just stay there 0. But I want to start when the moment the rock goes up. Okay, the moment the rock goes up, that velocity is 20, the initial velocity is 20. Okay, so we know what equation to do here. I don't want anything that got S. Don't want S, don't want S, don't want S. So it's equation number 1. You use the one on top or the one at the bottom also can. Okay, up to you. So I just use the normal acceleration formula. Acceleration is equals to V minus U over T. Acceleration is negative 9.81. V is 0. U is 20. T is just T. And whatever you do, right, should always make sense, because if you say something is slowing down, just now I was very sure I told everybody that if I throw something up 100%, it will slow down. Okay, then you ask yourself a simple question. Is it really slowing down? From 20 becomes 0. Yes, it is slowing down. So everything should make sense. These are not disconnected things. They are one system. Okay, this is one rock's journey from the bottom to the top like that. Okay, so make sure everything linked together. If you don't understand anything, why is it like that? Why is it like that? Just ask. Just ask. Remember, no stupid question. Just ask me. Okay, because something that you don't know, your friend also might don't know. Okay, just ask. All okay? Everybody okay? I know this throw stone up question is usually a question that some students have trouble with. Maybe hold on. Maybe I simplify this first. I times the T go up. Those of you who can do fast one, straight away jump to the answer, no problem. Okay, I'm just afraid some of you here might have a problem with this. I think the textbook one is quite confusing, the plus and minus. So I feel don't follow the textbook. If you're comfortable with what you learn in my class, good enough for SPM, good enough for your exam. Okay, 2.04 seconds. You want to make it more accurate, 2.049 also can. But I think don't need until more than that. Okay, I think this is already very good, 2.04. Okay, part B, find the maximum height reached by the stone. Okay, Ethan wants me to try. Ethan, can you send public chat? Okay, Ethan wants me to try if I use V equals to U plus AT. V equals to U plus AT. Also can, V is 0, U is 20, A is negative 9.81, T is this. So, oh, this is a lot faster. Oops, sorry. But same now, if you are fast, you can straight go there. So it's 20 divided by 9.81. Okay, same 20 divided by 9.81 is 2.04. Either one. Part B. The maximum height reached by the stone. Okay, so just now we found out what is the value of T already. Now we want to find out what is the value of S. okay, the maximum height. So we want to know from down here, go up, what is the displacement that this stone has traveled out, right? So I don't want to use anything that got t lah, okay? I don't want to use anything that got t. You want to use t also can because you already calculated the t, right? But remember that t is a value that you have rounded off. So it might not be as accurate as using those original values. Okay, so if you have a choice, I think don't use your answer lah from part A to do part B. Okay, if you have a choice lah, if you have a choice. So I think we don't want t for this case because anyhow you can only consider 4 at a time each time. So I don't want t, don't want t, don't want t, don't want t. So it's equation number 2. B squared equals to u squared plus 2as. Okay, V is what? V is 0, U is 20, A is negative 9.81. Okay, no wonder I got no space. Okay, negative 9.81. And then S is what we want to find. $400 minus 19.62s. Make sure all these values you can calculate yourself also. Okay. This one is a S. It's not a 5. Okay, so S is equals to 400 divided by 19.62. If you can do faster, you want to skip some of the working steps, it's okay. You can go ahead. Maybe we stick to 2.39 meter. 20.4 is also good. Okay, that means to go from the bottom to the top, it needs it will go through 20.39 meters. Okay, 20.39 meters. Got any question before we go on? So I need you to understand the A value, why is it negative 9.81, and the V value, why is it 0, then can already. Okay, so you just note down here, next time when you see you want to do back, or maybe you want to revise later, you want to go through again the same question. You can always go through again the same questions. These are quite good questions. Just take a rough paper and cover on top and try yourself. Okay, if you want to redo some of the questions. Okay, Ken? Everyone okay? At first find T and then after that find S. So that was the question. Okay, before I go on to 1.18, 1.18, let me know if you're not done. Let me know if you're not done. Before I go to 1.18, I want to explain something, right? If you throw something up, okay, the time taken just now was 2.04. And then you will reach this highest point and you will rest for a while. Just a short moment, just a split second before it comes down, right? the time here will also be the same. Okay, the time here also will be the same. Because why? The rate of you slowing down is negative 9.81. The rate of you speeding up is also 9.81. So you slow down by 9.81 and then you speed up 9.81 also. So one is negative, one is positive. It will eventually be, the left side and the right side will eventually be the same, exactly the same. Okay, and just a fun fact, right? If your original velocity is 20, let's say if we neglect the air resistance and all that stuff, okay, and then there's no wind to blow and stuff like that and slow it down or what. At first, if it's 20 meters per second, you go up 0, you come back down, it will still be 20 by right. Okay, by right. Provided that the only thing that affects the motion of the ball is the acceleration. Okay, because you go up negative 9.81, that's how much you slow down. You come down also positive 9.81. Okay. I'm not going to do air resistance, Ethan. I'm not going to do air resistance. It's not included in here. Okay. At least for now. Right. So air resistance is not included. Don't worry. So usually it's always ignore air resistance one. So U is go up and then U is come down like that. All right. So the thing here is that if you look back up in the linear motion equations for the symbols, right? I want you to take note about this one, constant acceleration. A is constant acceleration. Okay, so which means what? I can only use all the equations if the A is a same value. Okay, if the A is a same value. Okay, same value. So you must know that at first, when the ball goes up or when the stone goes up, the acceleration is this value. And then after that, when the ball comes down, the acceleration is this value. They are different. The number is the same, okay? The magnitude is the same, but the value, the plus minus is different. So at the end of the day, they are different now, okay? Because A must be constant acceleration. If you see, right, you have different sections of this journey of the ball, of this motion, that has different acceleration. You cannot treat it as one question and do, you must split it up, okay? You must split it up. That is why you might have seen your teacher, if they do something like this for this kind of question, especially in 2.3 later, freeform motion, you will see that they will split up like that. For those of you who don't know why, now you know, is because A is constant acceleration. You must use an acceleration which has a fixed value. If the acceleration is not a fixed value throughout the entire journey, you have to split it up. Okay, you have to split it up. That's why going up and coming down, I cannot say that, because some people will do like that. Some people will say, okay, I go up and then I come down. I go up, right? The velocity is 20. By the time I reach the floor, also 20. So some people might say, oh, I know already. The start is 20, the end also 20. Can I consider like that? No, cannot, because the acceleration going up and come down are somewhat different, right? If you say 20, 20, that means this ball is not moving at all. And not moving, sorry. This ball is just constant speed. It's just 20 all the way. But it's not the case, right? It changes from 20 to 0 first, right? And then from 0 back to 20, right? Yeah, so that's what I mean. You have to split it up into 2 sections. But just know that how long it takes to go up and how long it takes to come down is the same, right? Because the gravity is same. Okay, gravitational acceleration, the force that pulls you back to Earth is the same. Okay, it's the same. Understand why must split up? Everybody okay? Cannot consider the whole thing altogether because acceleration different. Okay, so that will bring us to this next question. Now you will understand better when we do this question. Okay, a tennis ball is thrown vertically upwards. Okay, at a velocity. So again, I only want to start when the ball, right, it starts to move. It starts to move. That means at the beginning, the velocity is 40 when it starts to move. And then by the time you reach the top, it would be 0. Okay, it will be 0. What is the acceleration going up? Okay, for those of you who don't know what is the meaning of G, G stands for gravitational acceleration. Same thing as acceleration. Don't have to worry the word gravitational for now. Just treat it as acceleration. Okay, I like to just use A. I don't like to use G one. A going up. So the question is now, should I put plus 9.81 or should I put minus 9.81, right? Now I think, oh, am I slowing down or speeding up? Slow down. Negative 9.81. Okay, you can obviously see from 40 meter per second become 0 already. So more not slow down. Right? If you write positive, salah already. That means you are saying it goes faster. Okay, this one goes slower. And then the part A asks us to find out what is the height. That means what is the distance that this ball has traveled so far. Okay, that is S. Okay, we got VASU. We don't want the T. Don't want T. So look at this equation, this list. Don't want T. Don't want T. Don't want T. Don't want T. Okay. Again, V is 0. U is 40. A is negative 9.81. S is just S. 40 squared is 1600. 2 times 9.81 is 19.62. S. Okay. I can bring this one come to the left side. Become positive. So S is 1600 divided by 19.62. Don't worry about the units as long as you make sure before you sub in, everybody is SI unit. Your final answer also will be SI unit one. Okay, maybe I write 81.55 meters. So the ball actually travels, tennis ball, 81.55 meters. I hope I didn't make a mistake. Okay, right. And then part B, calculate the time taken by the ball to reach the floor again. Okay, so this time, right, because remember, I cannot straight away calculate the time, go up and then come down, because I need to treat them as a separate scenario, right? First part, I analyze first, and then second part, I analyze later. So let's look at the first part first. Okay, let's look at the first part first. Remember why acceleration different? It's not in the same system here. Okay, we have to treat it as two different questions. We can split up the motion one. Okay, this journey we can split it up. So always remember, go up. This kind of go up, come down question always must cut into half. Cannot one shot one. Okay, cannot one shot one. So the time taken for the ball to reach the floor. So right now, I go and find out the T. I don't want S. I go and find T now. Okay. So don't want S. I want to find T. Don't want S. Don't want S. Don't want S. Don't want S. So that is number 1. Okay, maybe we use V equals to U plus AT. Okay, A equals to V minus U over T also can. V is 0, U is 40, A is negative 9.81, T is just T. Again, this one minus move over become plus. We will do more questions about this one when I reach 2.3. Okay. 4.08 seconds. That is just to go up. That is how long it takes to go up. Now the question is, how long will it take to come down? Okay, how long will it take to come down? You see, if you draw out, right, the V here is the same. Sorry. So for this system, now the initial velocity will be 0 in here. Okay, and then the V here will be 40. The A here will be 9.81. All the same one if you notice. The T here will be still 4.08. Okay, so you just remember if you go up and come down, if it travels the same distance, let's say from the ground up and then come back to the ground, the time taken will be the same one. Okay, the time taken will be the same one. So the total time is 4.08 times 2. Okay, 8.16 seconds. If you write a bit more decimal points, then your answer may be a bit different. Okay, if earlier you wrote 4.077, then when you times 2 the time, right, it will become 8.154. Okay, they'll accept both the answers, don't worry. Okay, don't worry. So either one, I think this is fine. Yes, Jashin, same time. Very good. Okay, so before I continue, I know the last two questions is probably not the simplest ones. Okay, so it's normal if you don't understand anything. If you don't understand anything, please ask now. Okay, please ask now. We explain and clear the doubts so that everybody is good to move on. Cherisha asks, why for B is the A a negative? Oh, because we're still looking at the, okay, don't get confused by the purple color part. I'm analyzing just the front part, right? Just the going up part. So I know what is the time it takes to go up. It will be the same time it comes down also. Okay, so I'm just focusing on the going up part. So the A is still negative 9.81 because still slowing down, right? Okay, can maybe you guys can jot down time taken to go up is 4.08. Okay, and then why we times 2? Because time taken to go up and come down are the same. Sorry if the space is very little. Maybe you guys can write here also can. Okay, at the empty space here. The 4.08 is the time taken to go up. Okay, 4.08 times 2, because the time taken to go up and come down are the same. So I hope at least next time you look back on, if you want to revise and what, you know what's going on, right? Because even for me, last time, many years ago when I was a student, this is how I study back, right? I go for class, and then whatever you learn is not going to stay there for a very long time, right? Okay, because you learn in class once only. So when you study back, let's say some things you don't understand, and you try to redo the question. As you do the question, I hope that whatever I explain comes back to you slowly. Okay, and why is it this? Why is it like that? Make sure you understand why you do all these steps. Okay, if you don't understand anything, you always just ask. Okay, can I move on? Everyone okay? Okay, last one, 1.19. Okay. Car P travels 10 meters per second and it is 19 meters from car Q. Okay. From here to here, they are 19 meters apart. Okay, 19 meters apart. When the traffic light turns red, the motorist from car P, okay, or the driver lah, motorist or driver is the same meaning, has the reaction time of 0.6 seconds. Reaction time meaning, right, because as a driver, if you see the traffic light turns red, it's not immediately straight away you press the brake, right? You need to see and then you process and then your leg only will go and step the brake. Okay, so this reaction time is the time for him to think. Okay, time to think before stepping on the brakes. Okay, reaction time. Nothing related to your chemistry reaction time and those stuff. No, just the time to think. When the brakes of car P are fully applied, the car starts to decelerate at 5 meters per second. Okay, so after he think, then he step the brake and then the car will slow down. Okay, slow down at this deceleration. Okay, so part A, they ask, how far has car P traveled during the reaction time? Okay, I'm gonna write down part A here because part A is really short. How far has P traveled during the reaction time? So when you imagine when the driver sees the traffic light turn red, that thinking time of 0.6 seconds, right? During that time when he didn't do anything, okay, when he didn't do anything, when he wasted that 0.6 seconds, how far has he actually traveled already? Okay, so we need to know that at the beginning, the velocity is 10, travels at 10 meters per second. Okay, at the beginning, the velocity is 10 meters per second, right? So all you have to do is just do velocity equals to, or how far has it traveled, sorry, the distance or the displacement is equals to the velocity times time, okay? Or you can do velocity equals to distance divided by time, displacement divided by time. So the displacement or the distance is just how far has he traveled times the time. Okay, I know this is U and I'm writing V just because V is like a general one. Okay, as long as I'm not using this list here, V can mean a general velocity, just like generally the velocity. You want to use U also can, up to you. Okay, I'm so sorry. S is 6 meters, X is displacement. Okay, so when he took the time of 0.6 seconds to think, he travels at that 10 meters per second, and he actually traveled extra 6 meters first before he stepped the brake. Okay, before he steps the brake. Part B, find the distance traveled when the brakes are applied. Okay, we do that one, we do part by part. Find the distance traveled when the brakes are applied. Okay, so you have a car, you go until okay, at first you travel that 6 meter, but that is when you were thinking still, so the velocity is still the same. Okay, by the time you reach here, the velocity also the same. Okay, by the time you reach here, the velocity also the same. But we are now focusing just on this part. Your velocity, right, is 0. Okay, your velocity is 0 because your brakes, when you fully apply the brakes, red light you cannot move already, right? So you have to stop. So the final velocity must be 0. But we want to know what is this distance. Okay, we want to know what is this distance. Find the distance traveled when the brakes are applied. So when he start pressing on the brake until he finally stopped, what is this distance here? Okay, that's what the question wants. Okay. Here they also put down 5 meter per second squared. That is the deceleration. So the A would be -5. Huh? Okay, can understand what is the situation talking about? This one is a slightly K-bar question for part B, slightly. So we analyze the back part. So at first it's the same velocity only. And then start to slow down. We are looking for S. So you look at this list. Don't want T, don't want T, don't want T, don't want the T, don't want T. So it has to be the second equation. Okay, second equation. You refer to your own list. I have V squared equals to U squared plus 2AS. V is 0, U is 10, A is -5, S is what we want to find. Okay, we slowly do. If you can, you try to draw out that that diagram that I also did. At first, it's 10 meter per second, and then after that, it will stop. Okay, so we found out that that distance there, right? This one, the 10 meters, is the distance when he start to brake up. Okay, when he start to decelerate, when he start to press brake. Make sure everybody can get the 10 meters out. Okay, last one. Will car P collide with car Q? Okay, Charissa, can I finish this first? Then I'll explain again. Okay, so S is equals to 10. Okay, S is equals to 10. That is the distance when you brake. Distance traveled when the car brakes. Okay. Will car P collide with car Q or not? Do you think they will collide? Do you guys think they will collide? Okay, Ethan say no. Kirina also say no. Yeah, they won't collide because the total distance traveled by car P is only at first the 6 meter. That is the reaction time, the time, right? Okay. When he was just thinking, he was still driving for 6 meters. And then after that, when he start to press brake, that is another 10 meters. So in total, 16 meters. But at the start of the question, you see, they wrote here, they are 19 meters apart. Okay, they are 19 meters apart. So they are 19 meters apart. So less than 19 meters. So they won't collide with car Q. Okay, so no, car P will not collide. Okay, car P will not collide with car Q. Then last one, how far from Q will P stop? Okay, what is their distance? One has traveled 16 meters. Initially, it was 19 meters. So their gap would just be 3 meters. Okay. Okay, 3 meters away from Q. Oh, okay, maybe I write that. P is 3 meters away from Q. Okay, so this part B a bit long. Charisha, can you understand the part A first? Everybody can understand what is part A talking about. The reaction time is 0.6 seconds. So that is the time that the driver take to think before he step on the brake. Okay, you see the red light, you're not going to straight away step. Okay, you still have to think for process it first, right? 0.6 seconds not a long time. Huh? Okay, it's less than 1 second. So it's a normal time, 0.6 second. So you see, you think, you step brake. Okay, that whole process took 0.6 seconds. Right? So how far has it traveled during that 0.6 seconds? 0.6 seconds times 10 meter per second. Right? So he has traveled 6 meters when he was thinking. And then after that, we look at part B. Okay, this is for those who are a bit confused with what is going on in part B. At first, he traveled 10 meters per second, driving. He continued on driving for 10 meters per second for 0.6 seconds. Okay, for 0.6 seconds. And then after that, 0.6 seconds, that is when he starts to step his brakes. The moment he steps his brake, he will slow down. He will slow down. This is the moment he starts to step his brake. He will slow down until he reach 0 meter per second. You see a traffic light, you definitely want to stop right at the end. So stopping, resting, the velocity always 0, right? The speed 0. Okay, so this is why I put V equals to 0. This one I put myself on. Okay, and then the question also mentioned the deceleration is 5 meters per second. Because he's slowing down, slowing down means your A value must be negative. So it's -5. Okay, we are looking for the S value. So you have U, you have V, you have A, you want to find S, you choose which formula. Okay, we ended up with this formula. Put in the values, you will get this S equals to 10. Okay, put in the values, you will get S equals to 10. S equals to 10 is the distance traveled when the car brakes, right? During, I don't know how long it takes for him to brake, but when the car braked that time, he had to travel for another 10 meters. You cannot brake on the spot, right? When you brake, you will still move a bit, right? So you brake slow. Usually your cars, they will brake slowly, right? So when you brake over a distance of 10 meters. Okay, so the total distance traveled by P, this part here, total distance traveled by P is actually the 6 meters plus the 10 meters. Okay, 6 meters is when he was still thinking, 10 meters when he pressed the brake. Okay, so this one is when he was thinking. This one is when he stepped brake. Okay, 6 is when he think, 10 is when he step brake. So the car will not collide. The car will not collide because they were 90 meters away, but you only travel 60 meters now. So it collide meaning it won't hit car queue. Okay, it won't hit car queue. And they are 3 meters apart. They are 3 meters apart. That's the last part. Okay, cannot, Cherisha. You understand that diagram that I drew, right? Okay, can I? Everybody okay? Okay, can. Good, Cherisha. Okay, I know usually in class, some of you are faster, some of you are slower. That's very normal because we are a group class. Okay, I try my best to accommodate everyone. So if you feel that you're a bit faster, right, you can always do the objective questions while waiting. Okay. Okay, you can do the objective questions while waiting. Can? I'll give you guys the answer for the objective questions here. All right. Please try yourself. Please try yourself. I will go through maybe just some of the questions. Just some of the questions. Maybe question number 4. Okay. Maybe question number 4. Let's go through this. I like to do theory questions. The diagram shows a ticker tape obtained from an experiment to study the movement of the trolley. So, okay, this diagram is not the best diagram I know, but it's clear enough for you to see. This is the beginning part. That means the ticker tape goes in here. The ticker tape, this one is the end part, right? Which statement describes the movement correctly? Okay, so the first one, we go through one by one. The trolley is moving with uniform velocity. Do you guys think A is correct? Yes or no? Is it moving at constant velocity, uniform velocity? I mentioned about this before, right? No, yeah, Kirina says no, thanks. That's right, very good. Okay, because the value here definitely different, no? So number 1 is wrong. Huh? Number 2, the trolley is moving at constant speed. Also wrong. Okay, speed and velocity very similar, right? Number C, the trolley is moving with positive acceleration. Yes, because it is speeding up. Okay, let's see why is D wrong. The trolley possesses a negative acceleration. Possess means have lah, or has a negative acceleration. That means slow down. Is it slowing down? Nope, it's not slowing down. So D also wrong. Okay, negative acceleration means slow down. Positive acceleration means speed up. Okay. Oh, I think there are some graph questions here, which is a crossover with the next topic. Okay lah, I let you guys do it. It's really helpful to do objective questions, and it really tests you on your understanding. The space here won't be enough for you to do your working for the calculations, definitely. So you can write it in a rough paper and just staple it behind or whatever. Okay. Can? Let's move on to 2.2. Later I'll send the answer to the group. So you try yourself some of the questions. Don't have to do straight away in this week. Okay. I'll send into the group, the WhatsApp group, as a picture. So I think you write it down somewhere. Okay, if you haven't done it. Okay, you write it down somewhere first if you haven't done it. Then later on when you do ready, you can check your answers. Okay, my answers are not always correct one. So if you feel that something is not right, please always check with me. Okay, you can WhatsApp me or you ask me in class also can. Okay, linear motion graphs. The first thing is I need you guys to remember this. Displacement, velocity, acceleration. The symbol for displacement is S. The symbol for velocity is V. Symbol for displacement is S, velocity is V, acceleration is A. Okay, I need you guys to remember this order. SVA. Okay, remember this order, SVA. And for you to go from S to V or V to A, for you to go forward, for you to go in front, you are always looking for the gradient. Okay, for the gradient. This top thing here is probably the most important thing you need to know for this topic. For you to go backwards, you need to find out the area. Okay, area. You learn in chapter 1, right? One of the one of the few ways to analyze a graph is by finding the gradient or finding the area. Okay, so this is when it is very useful. Okay, this is when it is very useful. Later I'll explain to you why is it gradient and area, but for now, make sure you remember this, especially for those who are going to sit for exam, make sure you know this. Okay, later I'll explain what it means. Okay, so starting with the first type of motion, if you have this kind of graph, okay, if you have this kind of graph, let's say this is 10 meters. You imagine what that means is this person is just standing 10 meters away from the original point. He's just standing there, not moving. Displacement is the same. That means that the person is at rest. That person is at rest. Okay, so this one is displacement time graph. This one is velocity graph, velocity time graph, right? So at rest meaning that the velocity is 0. But I also want you to understand this based on the concept of going forward, find the gradient. I need you guys to know why is velocity 0. Because the gradient of this line is equals to 0. Okay, anywhere on this line, the gradient, they are all 0. The entire straight line, the gradient is 0. Okay, horizontal line always 0 one. Okay, I hope you know that. That is why we get 0. So without really understanding what this means, if you can find the gradient, you can always know what is the velocity. Okay, next one. Now this one is also a horizontal line. So the object at rest not speeding up, acceleration also 0. Okay, but basically the gradient here also 0. That's why we get 0 as well, right? So object is at rest, acceleration is 0. Next one. Now this person starts moving from 0 meters and then walk. And then eventually, let's say he reached here 10 meters at it. All right. So after some time, he reached that, right? So what we can say about this graph is that the displacement is increasing uniformly, or it is a constant velocity. Again, how do I know that it's up here and not down here this time? You must ask yourself this very simple question. From here to here, find gradient, find gradient. What is the gradient of this line? Is it just one fixed value? I hope your answer is yes, because one straight line, the gradient value is the same, right? Whether you say the gradient of here, of here, of here, of here, they are all the same, right? So therefore, let's say the gradient value is 5, for example. Okay, at here also 5, here also 5. Yeah, hold on. Okay, sorry, I saw it coming. My OneNote crashed. Let me share screen again. Okay, yeah, we're back. Anywhere on the line is also 5. Okay, 5 is just a value that I simply put. Okay, at one point is 5, everywhere else also is 5. The gradient is the same value. So that means that the velocity is 5. Okay, that means that the velocity is 5. It will be 5 all the way. Okay, the speed is 5 all the way. Can? Right. So if the velocity is just 5 throughout from the start to finish, velocity is 5 from the start to finish. The question now is this thing speeding up or not? No, right? Just 5 constant velocity throughout, not getting faster, not accelerating, therefore acceleration is 0, right? If you understand that, very good. But let's say you remember the gradient concept, also very good, because if you find out the gradient of this horizontal line, any horizontal line, whether is it on top at the 0 there at the bottom, it will always be 0, gradient. Okay, gradient, the symbol for gradient is M. The gradient is always 0. That's why it is 0 like that. 0 here, here also 0, here also 0, here also 0. They're all 0. Okay, and next one. Okay, these two are the interesting ones, right? The one that people get confused. If you see that your displacement curves like this, okay, I want you guys to see that this part is flatter this part is steeper. Okay, steeper means sharper. Okay, steeper, or you want to write sharper also can. Right, at first it's flat and then it goes up really fast. What this means is at first, right, you are walking slowly and then you eventually walk faster and faster and faster and faster, right? At first you walk slowly, slow walk. Okay, the distance increase very slow. And then after that you walk really fast. So it's getting flat to steeper. The gradient is increasing. Okay, the gradient is increasing. When I say the gradient is increasing, it means that the velocity also increase. Okay, how do I know that the gradient is increasing? Let's say at this point, the gradient is this value. Okay, let's say at this point, the gradient is look something like that one. Wait, okay, let's say at this point, the gradient would be something like okay. I know a lot of you don't understand why I go and draw a straight line, right? But because the gradient keep changing at every point, if it's a straight line, the gradient is just one fixed value, right? If it is a straight line, the gradient will keep changing, keep having the same value. Sorry. If it's a curve, the gradient value will keep changing. Okay. And how does it change? You can actually draw a tangent line at that point only. Because tangent only touch at that one point, right? You learn in Form 3. Tangent means a line that touch one point only. Okay. So you can you see or not the straight line from a flat line, it becomes steeper. When I say steeper means more and more difficult to climb this slope. Okay, more and more difficult to climb this slope. Becomes steeper and steeper. So as you go up, you're actually getting faster and faster and faster. That's why the velocity is increasing. Okay, remember, so if you curve like that from flat go up, the gradient is increasing. You can actually replace the word gradient. You can actually replace the word gradient because the gradient of this graph is what? Velocity. Okay. When I say gradient is increasing, it also means velocity is increasing. That's why the velocity increase at it. Okay. And then now from here to here, I need to go and read what is the gradient again. The gradient value for a straight line like that, horizontal line is 0, but any slanted line, okay, as long as it's a straight line, slanted line, it's just one value. The gradient here, all the same. That's why it's just one fixed value. Okay, so velocity is increasing uniformly, but you have a constant acceleration because it's a straight line. Okay, what is the, so this one means it's slowing down. At first walk very fast, okay, at first very sharp, okay, or very steep, and then after that becomes flat. That means eventually, flat, that means at here, let's say you walk until 10 meter. At here, let's say you walk until 10.2 meter. So it becomes very, very slow. Okay, it increases very slowly. That means you're slowing down already. At first, you walk very fast on. At first, maybe 0. And then maybe the next second, you already walk until 4 meter already. Okay, very sharp at first, very fast at first. Then at the end, it's very flat. Okay, means what? Slowing down. Gradient is decreasing. Velocity is decreasing. Okay, velocity at first very fast, very high value. Then slowly drop down. Okay, slowly drop down. It will touch until here if this person walk until he stop. If stop, then will be v equals to 0. Okay, if you don't know whether got stop or not, then usually we just let it. That's why it's floating like that. Okay, if it continue walking until it stops, then it's here. But the gradient value now from v to a, from velocity graph to acceleration graph. This gradient could be a negative value, let's say -5. Okay, that's why down here is -5, which makes sense. If my A is -5, decelerating, slowing down, which also makes sense. Let's say V here is 10 meter per second. Then here, let's say is 2 meter per second only. So slow down already. The value on the speedometer when you're driving becomes a smaller value. You're slowing down. Okay, so I just want you to remember that going forward from S to V to A, very important, huh? From S to V to A, find the gradient. Find the gradient. Okay. I know this can be a bit confusing, but flat go up means it's getting faster, and then become flat, that means slow down. Okay, becomes flat, that means the gradient is decreasing. Okay, I move on now. So we look at our first question. The displacement time graph shows the motion of Ali walking. Briefly describe the motion of Ali for his entire walk. Okay, they don't usually ask you to describe like this entire walk like that lah. So this part A is more for you to understand better what is going on. We have a displacement time graph, right? And then we have the time here. So point O is the original position. At first, this person walked from 0 meter to 100 meter. Okay, and Ali took 200 seconds to do that, right? So we can talk about the first part first. Huh? Okay, for this first part, it can be something like this. Ali walks 100 meter away from the origin. Okay, like I said, this question, part A, is just for you to understand better what is going on. Ali walks 100 meter away from the origin for 200 seconds. Okay, you can even say that he's walking at constant velocity. Right, the important word is this lah, because let's say if the question asks you to state the type of motion for this first part, you can say constant velocity. And then after that, here is at rest, because it's not moving. He's just there at the 100 meter there, never move. And then this one is also constant velocity. Okay, and then after that, so that's just the first part. And then he then rests for 100 seconds. Okay, that's it. Ali then walks 100 meter towards the origin. For 200 seconds at constant velocity. Okay, Ali then walks 100 meters towards the origin for 200 seconds at constant velocity. So by the time he finished that 200 seconds, he will already reach back to the original position, because at first he walked 100 meters away and then he walked back now. Okay, and then he walked back. I don't want you guys to think of this as the distance. Huh? This is not the distance. All right. Why suddenly become less and less and less like that? So basically, he walked to here and then he stopped here and then he walked back. Okay, this is what is happening. For those of you who always get confused with the idea of displacement, right? You can always think of displacement as the position. It's like coordinates like that. Okay, it's like coordinates like that. So at first it is 0 meter, and then he will slowly until he will reach 100 meters. Okay, it's like coordinates like that. Then from 100 meter there, he will slowly walk back, and then he'll reach 50, and then slowly come back until 0. Okay, so the displacement is like position and it's like coordinates like that. The point O is always the original. So any original position, I can call it point O1. Okay, so you can draw a mini version up here. At first 0 meter and then 100 meter. So Ali walks to here and then walk back. Okay. Part B, how long did Ali stop walking? Okay, this first question, because it's the first question, so it's supposed to be easier a bit. He stopped walking for 100 seconds. Okay, he stopped here for 100 seconds. That is this part, he stopped here. Part C, after how long did Ali take to return to his original position? In total, he took 500 seconds, right? So he started walking, and then after 500 seconds, then only he returned to his original position. Okay. D, find the total displacement and the average velocity. Okay. Can anyone tell me what is the total displacement? Yes, very good. Thank you, Jashin. Thank you, Sherwin. Thank you, Ethan. 0 meters. Okay, because you start and you stop at the same point. Displacement is 0. Okay, they say total because they're referring to the entire journey. So the average velocity, also 0. Okay, I hope you know why is it 0, because displacement is 0. The time I know is 500 seconds, but it's still 0 at the end, because displacement is 0. Okay, then E. Now we want total distance. Total distance is at first travel 100 meter and then come back also 100 meter. That is 200. Okay, average speed, 200 meter divided by 500 seconds. Okay, I know that Ali stopped for a while here, right? So some students may ask, like, do we have to minus off that 100? Don't have to, because we are referring to the entire journey. So including whether he stopped or do whatever in between, we want to know for the entire journey. Okay, so the average speed usually is for the whole journey. So just 500 seconds, and that would be 0.4 meter per second. Okay. Next one, F. Find the velocity of Ali at 100 seconds. Okay. This is when I will do this. S to V to A. Must remember this. What graph you have, you circle it. Okay, this is what I will do in every single question. I have the S graph. I want to find what? I want to find out the velocity. So going forward is finding the gradient, finding the gradient at 100 seconds. 100 seconds is here. Okay, now I want to ask you, right? The gradient at this point, can we find gradient at 1 point or not? Usually your gradient formula also has 2 points, right? 2 points. you will do y2 minus y1 over x2 minus x1, right? Usually it's 2 points. But then, since we know that if it's a same straight line, whether it is the gradient here or here or here or here or here, all the same. Okay, the gradient are all the same. Because it's one straight line. Takkan your gradient here is 2 and then here is 4. Cannot be. They're all the same value. So you can just use the points that you know, these 2 points. Okay, what I like to do is, I like to use this formula, the gradient, the velocity at 100. Velocity is equals to, I like to just take the distance in y over the distance in x at it. Okay, the distance in y over the distance in x at it. So that one, vertical distance is 100. That is my delta y. Okay, y distance over x distance. So that is 100 meters divided by 200 seconds, which will be 0.5 meter per second. Okay, 0.5 meter per second. At 250 seconds, the velocity is the gradient of this line. So again, you ask yourself the same thing. Go up here. I got S, I want to find V. I look for gradient again. For horizontal line, the gradient is just 0. How do I know? Because there's no y distance, it's just 0. Okay, this fine gradient one you learn in chapter 1. 0 divided by 100 seconds, right? So you can straight away write 0 meter per second. Okay, at last one, so 250 was in the middle. And then last one, 400 seconds. 400 is also in the middle. So at any point, the gradient all the same one. Okay, you can just do the y distance over the x distance. Can you guys tell me if you don't know what I'm doing for the gradient here? The y distance over the x distance. The y distance here is again 100. The x distance is again 200. But this one a bit special. I need you guys to put a negative. Any line that looks like this is a positive gradient because it's going up. Going up. Any line that goes down like that is a negative gradient because it's going down. Okay. Going up, positive, going down, negative. So the disadvantage for this one, y distance over x distance, is you have to put in the plus or minus yourself. So it's something like that. I know some of you may ask me, teacher, can I use the y2 minus y1 formula over x2 minus x1? Can, no problem. Okay, but first thing, you need to write out your coordinates, right? So for this line, for example, okay, the coordinate here is 300, 100. Here is 500, 0. So the gradient would be y value minus y value over x value minus x value. You will still get the same thing. And if you do this straight away, you don't need to worry about your plus or minus sign. It will take care for you, this formula. Okay, so I prefer to just, because it's very easy to just see what is the y distance and x distance. So I like to just take the values and then put plus or minus myself. But if you feel that you are afraid you might make mistakes with the plus or minus sign, then you do this. But I think it's good for you to be aware of when is it plus and when is it minus. Plus like that, minus like that. Okay, plus is going up, minus is going down. Okay, increasing, going up. I like to remember it by the letter A. Capital letter A is like that, right? Plus, minus. I don't know, for some reason it has stuck with me, this capital letter A from a very long time ago. That's how I remember every time I'll think of the letter A, and it just has been in my mind. Okay, last part. Oh, sorry, a bit late already. Let me quickly finish. Sketch the velocity time graph for Ali. So you draw a graph like that. Okay, at first, the gradient for the entire line from 0 to 200 is 0.5. The gradient is positive 0.5 for the whole line. Okay, until 200, it's all 0.5. And then after that, the gradient, I'm referring to these three values, 0.5, and then it becomes 0, and then it becomes negative 0.5. The gradient for the entire line from 200 to 300, it was just at 0 there. From 200 to 300, it's just at 0 like that. From 300 to 500, the gradient is negative 500. A negative 0.5, what am I saying? Negative 0.5. Okay, usually, right, we don't leave the line hanging like that one. So we usually connect it with, you can connect it with a dotted line, or you can connect it with a solid line also can. Okay, usually we don't leave it hanging. So you can connect it with a dotted line. That means, right, at first is 0.5, traveling at the speed is 0.5 meter per second. Then is the Ali will stop very abruptly, suddenly stop there. Okay, he walk, and then he stop there. Okay, he walk, and then he stop there for 100 seconds, and then he walk back. All right, and then he walk back. I just want you guys to know, so this is it. This is done already, the whole question. I just want you guys to know that positive velocity means move to the right. Negative velocity means move to the left. Okay? Negative velocity means move to the left. You look at your notes, the first page. Okay, you look at your notes, the first page. There's the table where I wrote, when is it positive velocity? When is it negative velocity? So which makes sense, Ali moved to the right and then moved back to the left. That's why he will come back to the original position. Okay, so the value of positive 0.5 and negative 0.5, these two, same speed, but different direction. Same speed, but the plus and minus tells you that they are different direction. Okay, they're moving equally fast, same speed, equally fast, but one is moving to the right, one is moving to the left. Okay, so now I hope you are very, very certain of when is the velocity plus or minus. That is talking about the direction left or right. When is the acceleration plus or minus? That is talking about are you speeding up or are you slowing down? Acceleration plus or minus. Okay, all good. Sorry, a bit late. I will stop here. Good luck to those of you who are having exam. If you got any questions that you want to ask me, you can WhatsApp me. Okay, if you are okay, you can. If you're okay, you can go. Okay, Bradley asked me to try. Welcome. Bradley asked me to try the objective question number 2. Okay, everyone done with this? Let me try. The diagram shows a teenager skating along a straight path. Velocity decreases from this to this, moves through a distance of. Okay, so the U is 5, V is 3. Okay, moves through a distance of 16. Deceleration, maybe I count the acceleration first. So I look at my formula. I don't want T, I don't want T. So I go up. Look at this. I don't want T. Don't want T, don't want T, don't want T, don't want T. V squared equals to U squared plus 2AS. So V is 3, U is 5, S is 16, 3 squared is 9, 5 squared is 25, 2 times A times 16. I can times 2 times 16 first, 32. So 9 minus 25 first, negative 16. A is negative 16 divided by 32. A is negative 0.5. Oh, I think the question should say, what is his acceleration, right? So acceleration is negative 0.5. Then deceleration is positive 0.5. Okay, but I can get the answer lah, but this one is supposed to be acceleration. Yeah, I think there's a mistake with the question. Ken Bradley? Yes. So if you see all these things, right, you see whether can list out or not. The moment you see this list getting longer and longer and longer, it usually means that it is one of the linear motion question. That's how you spot. You don't have to stress about, oh, I don't know which one is which. If you're able to write out the initial velocity, final velocity, then the distance like that, then it's usually a linear motion equation. Okay, you guys can go. You guys can go. Don't need to wait. So you try this one. Those of you who can, you try. Okay. Welcome. Bye bye. Bye bye. Good luck if you're having exam. Welcome. Oh, don't worry. No worries. Don't worry, Bradley.